Jose J.G. Gonzalez. See you tomorrow, bro. Thank you.
Oh my god. Gleam's such an idiot.
Al, really quickly. Are you still here?
Yeah.
Al?
Yep.
Right, yeah. So I'm sharing my screen. Is this what you meant? So I've got a 50, what is it? A 50 odd kilometer bloody stretch of whatever. Camera at 2 meters or 2.3 meters. On a focal length of 24 millimeters on a 35 millimeter sensor. So that's the equivalent is 24, which you'd have if you didn't have a full frame sensor. Pointed at I don't know, this lighthouse down here with a single kind of light source on it. Is this what you wanted?
Pretty much, yep. It was to replicate a real world situation.
Because at 24 millimeter wide angle down there, at this distance, you just would not see this at all.
Right, so I don't know. Let me see if I took the specs.
You did say this was 15 meters high, yes?
I think it was 18 meters for the lighthouse.
Oh yeah, sorry, yeah, no, that's right. I've got it at 18 meters. Yeah. I've actually got that at 18 meters.
So basically, if it helps, in case that there's any inaccuracy in the thing that I pasted in with the camera specs, it's the Mavic Air specs.
Oh right, yeah. No. I do believe that 24 will be pretty accurate then, because I do have quite wide-angle lenses on that, and it's non-variable focal length. So yeah, it will be about 24 millimeters.
It would be very small, very difficult to see, but
if only you put your powers to good, honestly.
So
that's pretty much it.
Yeah, so looking through this with a 12 megapixel sensor gets me. I cannot see that at all on the distance, and this is a perfect demonstration of the Rayleigh criteria. In a second, give it a sec. Oh no, wait a minute! I need a light source in there to light it up. Give up! Stop! Yeah, so even going, are you proposing that if you went up, you would be able to see it? Is that your kind of view on that?
Well, are you on the flat or the curved surface just now?
Flat. I haven't built a curved one yet.
Flat, right, okay. Well, obviously, I'd like to query whether any flat earthers think that the light source would be visible across the flat plane.
Well, I'm not casting a volume light at the moment. I can, but then that doesn't tell you whether you can see the object, which is the important thing there. So the sheer fact that you could see a light, I think someone said in the panel, it might have been Rumpus, you can see a star's light, but you cannot make out the angular size of that. But it would be the same for this object over this distance.
Yeah, it's the light obviously is the important part, not the object. You wouldn't expect to see that. It's the light itself.
It's all about how light reflects, right? And a lighthouse main component is the light, and it's a very technical piece of equipment. Look it up. So it's a very exacting, and of course it's designed to give the maximum extents, I guess.
Oh yeah, no, it gives a nice sort of like lensing effect to kind of shoot it out. And so the experiment here is, would you be able to see this light source here?
Yeah, well,
from
the idea
that
is
distance
to obviously check with people like Pete and Mog whether they think that the light from the lighthouse would be visible from the camera at that distance, and if not, why not, and what you could do to make it visible.
Right, get you. I get you now,
Because
I think.
from our point of view, there's nothing obstructing the light, so there's no reason why it can't be seen. The only thing which might cause an issue, obviously it might be harder to render it in a program as it would be to see it in real life, is the size, the visible size of the source of the light.
Right, get you. Yeah, I'll tell you what, I'll save this, and I've saved it as an AL-K thing, and I'll do a equivalent, and I will put a volume shader on this light to kind of simulate kind of the fall-off area and dissipation that we're going to get on that light to see if we can. Well, you would be able to see it on a flat surface at the end of the day.
It's not a good test bed for a conclusive thing, because you guys will just say loom and then we'll say optics.
Well, optics is just a phrase. Again, it doesn't tell you
So
how
is
anything
looming,
works.
sir.
So
is looming, genius.
No,
no,
looming is
a specific aspect of refraction
yeah.
that describes a specific physical thing that's happening.
Would you say it's
Optics is
optics?
just a broad
Did you
term.
say it's optics as well, or is it something else?
I just said optics is a broad term. So if you're saying it's optics, you need to say which optics, what is actually happening with the light.
Yeah, looming's not real. It's just optics. That's all you guys will use.
No, mind of God, looming is the word that we use to describe what happens with, due to refraction, objects. It's a descriptive term.
Sorry, hold on a
Whereas-
second. Chris Berry,
Chris,
there's something
you're
going on
making a
with
hell
your
of a
microphone.
noise.
You're just making
So-
noise.
I asked Rumpus, what's
Wait a
causing
minute,
the
Pete. Wait a minute.
mirage?
Hold on,
Just-
Dean was
just-
in mid-explanation,
Yeah,
Pete.
just 2 seconds. So, mind of God, it's an explanatory term. We could call it flunging or flobby, but it describes something. Whereas
Right.
optics is a physical thing. It's like me saying stone, table. That is not a description of an effect of something. It is just an object. Now, so when you say optics, what is it that you mean?
So when you say looming, you mean that
No,
something
that was
is
to
looming.
mind of God.
Pete, for God's sake.
I know that, but when you say looming, you mean something is looming, right? So when you describe the phenomena as looming, it's not the correct phraseology that you're using.
It is the correct phrase.
No, it is.
Right, and let's not get buried into the whole definition of things. At the
Things
moment.
are loomed
Right.
up.
There's a
Yeah, so
specific
it's things are
example on
loomed.
the table, and Mind of
Well,
God
the light-
raised the issue of optics. He's welcome to use whatever aspect of optics he feels applies to this situation and say, can we see the light from that lighthouse from that distance with that camera? And if not, why? And what could we do to see the lighthouse if we can't?
Why are you doing this, man? What's the point
Which
of
light-
Which lighthouse is this, by the way?
Yeah, put it up.
Dean, it's Dean's Mind of God. Click on Dean. Pete,
Where-
you're playing your guitar. Jesus Christ, we're trying to talk here.
Shut the fuck up, bro.
Mute
It's just
yourself.
You shut up. Mute
Yeah,
yourself.
what the hell are you doing playing music while people are trying to talk, you prat?
He's trying to disrupt the whole thing.
Yeah,
That's what he's trying to
wanker.
do because he doesn't like what's being presented.
Yeah, so Dean, so Mind of God, Dean is trying to present something here if you want to see what's...
Well, no, it wasn't. It's an experiment that Al is going to do with the drone and stuff. But
Oh,
we were.
right.
No,
I hate niggers.
I've already done it.
Oh, God.
Oh, have you?
Yeah, so this is why I want to see what flat earthers have to say about it.
Right. Okay, now I get you.
Yeah, drones will solve it. More stuff with drones is good.
Yeah, I've used a drone mog. You talk about them, I'll use them. So
Well, why
it
didn't you
seems
end?
how you're not a technology denier, apparently, according to your rhetoric. Why don't you tell us what the drone would see from that distance when looking at the lighthouse over
I
your
would-
supposed flat plane?
I would do a test that doesn't depend on optics if I could. I mean, you can still use it to do other things. I'm not saying it's bad, but
So we're
Those
using a
static-
drone,
those
but we're not
static
paying
pictures.
attention to what the camera sees in the drone.
no, you can make it part of the test. I just think relying on it completely, I think is just difficult because, like I said, we would just say one thing and you're going to say something else, and just that's what it'll be. We think we're looking out over a flat surface. You think you're looking out over a curved surface. So, and
we
that's
can
what we're
prove
seeing.
that we're
Yeah,
looking
and
out over a curve surface.
Exactly, depending on which one it actually is, you get different results. So, what would you?
Yeah, but
what
it's
would
difficult
your
to do
results
that
be?
when you guys,
And
when we don't have agreement, because like we would use everything we see and model a flat Earth that way. You're modeling it as if it's curved. So, like I said, it's a difficult place to come up with a conclusive test.
doesn't even make any sense.
Sir, you guys are assuming you're looking over a curved surface and saying that that's what you see is what you're modeling. We would, if we went through the trouble to do that, we would model it saying the Earth is flat and this is what we see. This is what the model would do.
Right, exactly.
Show
So
us
I'm
the math
asking you
on
to
that,
do.
and
I'm
are
you
asking
a
you to
moron?
say the Earth is
So-
flat. What is the result from the drone?
So what you'd have to take into consideration is all the components involved, right?
See, well, what I'm getting here is
You
that
have to
none
take
of
into
you have an
account the
answer.
distance. You have to
None
take
of you
into-
can even begin to
hang on,
explain what you would
have to take
expect
into
to
account
see
the
or
water.
why.
You have to take. I was speaking. You have to take into account the water beneath and its properties and how it would behave over a flat plane. You have to take into account the properties of light. How do we see light? What should we expect to see from what distance? All of these different things. Absolutely.
Gibberish.
We do.
Not gibberish. Are you saying you don't have to take into these
So-
these
We
things into
do take
account?
that into
No,
consideration.
nothing you
Pete.
said had to be taken into account.
If you're looking over a
Can I ask
stretch
a
of water
question
that's
while I'm
30
on
miles and you're assuming that it's only over a stretch,
Anyway, Al was in the middle of saying something, I think.
I'll leave in a second. If you're looking
Listen,
over a
Chris.
stretch of water that's 30 miles in length and you assume it's only 4 or 5 miles, whatever you come up with in terms of explaining any phenomena will it be at variance,
Jesus
right?
Christ. It doesn't matter which assumption you make, right? The point is that you take both and that you model them out or figure it out whatever way you want to do it, and then you do your real world test and you compare which result
Did you just say it doesn't matter
matches.
what assumptions you make? Did you start your sentence off with that, genius?
Say that again.
Did you start your sentence off with it doesn't matter what assumptions you make? Did you just say that?
Yeah, it's right. He's saying
Yeah, it
you can
doesn't
make
matter
any
which
number of
assumption you make
assumptions.
with regard to the shape.
You
You're a
start off.
dummy. Sir, you're an
No,
idiot.
it's not. No, Marty, you got to
You're a dumbo.
you make some assumptions. You see what those predictions and those assumptions result, and then you compare that against reality. And then the ones that assumptions that don't match reality, you reject, and then you're left with the assumptions that do work, i.e., a sphere.
But saying the assumptions are arbitrary is what an
They
idiot.
are arbitrary. You can have a banana. We could assume a banana-shaped Earth, then see what the consequences would be on the geometry of what we would see, and then we can say, "Oh, look, it doesn't match that. Therefore, it's not banana." You can make any assumption you like about the shape of the Earth, provided you can work out the consequences.
If there's not enough of them to ensure that what you're seeing can only be seen based on those assumptions, it's a useless test. That's the whole point. They do matter. They have to be the right ones because that's the.
No, they don't.
That's the quote
You can
unquote.
make any number of arbitrary assumptions about your model, and then you test it against reality, and then you throw away the ones that don't make the correct predictions.
But
about
Rumpus,
what you see.
I think you would agree because Alkay doesn't know anything. So if you make those assumptions and then you do an observation, you're essentially then mapping that reality to those assumptions and saying that there's essentially a one-to-one to those, right? You
determine the predictions that you're. If I assume a banana-shaped Earth, and I say it's a certain radius around the girth of the banana, I then say we should be able to see. Looking along the banana, you'll see this far, and if you look along to your right, along the girth of the banana, then you will have another different curvature of the Earth. We can then say, right, let's go out in the field and then see, looking using a theodolite, what the dip to the horizon is. We'll say, oh look, then this does this. So, say, oh, it doesn't match the banana shape, therefore it's wrong. So we then go and throw that away and then start up with a new model.
You just answered. You just explained my point, but go for it.
Rumpus.
Yeah, because you didn't understand Al K's point.
No, his point is stupid.
He said you can start off with arbitrary assumptions, but you then have to work out what the model using those assumptions.
No, those assumptions need to ensure that what you observe will be uniquely represented by those assumptions.
Duh.
Well, why
okay.
do you arbitrary then,
Jesus
dummy?
Christ, man.
So you're saying you can have several models and you want to make sure that they don't have duplicate results. Is that what you're trying to say?
Of course. Okay, that's why we're here. What do you mean? That's why
we know. Well, we know there
every day.
Right, but none of us. We do not have that problem. The spherical Earth makes a lot of very different predictions from a flat Earth, and all the results we get show a spherical Earth. We don't have this problem of
You're allowed to hold that opinion. You're allowed to hold that opinion. I'm not saying that. That's
right,
wrong.
For start, the spherical Earth
but to say the assumptions
the ship's
are
going
not
over the horizon will sink bottom down. It also predicts that if you use a theodolite, the horizon will be down.
You're allowed to
see in the real world.
You're allowed to
come
to that conclusion, but to say the assumptions are not important is what an idiot would say.
No, the assumption's not a point. You could, as I say, you can have a banana-shaped assumption.
It's just the first part of the process of elimination. You start with some kind of assumption. Then
I wasn't talking about assumption. I was talking about taking all factors into consideration. I wasn't. Shut your mouth. I was talking about taking all factors into consideration.
The Earth is concave.
Later.
And then you see what the consequences of a concave Earth would be.
Just guys, just really quickly, because someone's been patiently asking, can he ask a question? Chris, you had a question for Al, was it?
Yeah, I need to know. We need to know the distances to Al's turbines in the photo that Rumpus uses. I also need to know which camera you used, Al, and the millimeter zoom length, focal length.
Rumpus, do you have that handy from when I gave it to you the other day?
I haven't. I'm about to model this exactly. I'm about to get the distances to these wind turbines, but I haven't done it yet. I've been a bit occupied yesterday, and I was feeling a bit poorly as well.
Think that there's that much blockage, but the things would not tilt back like an absurd amount? You really believe that? By that?
You stupid bastard! We've explained.
We have
explained the mind of God. how little over 69 miles you would require to get 1 degree to bend. And I can't believe it. You claim to be intelligent, and yet a 13-year-old could understand they couldn't see a 1 degree
Rumpus,
dip. I mean,
why
how stupid!
you
How
act like a
stupid! Don't
nigger
interrupt. Timar, shut up.
on YouTube?
My
You
God,
shut
how
up,
can
you
you be
fucking
this
nigger.
stupid? I mean, you are
How can you
behaving.
tell me to shut up when
You
you
claim
act
that
like a
Al's K is
fucking
not
nigger
educated, and
on
you're
YouTube
demonstrating you
all
are really
fucking day?
stupid. If
How
you
do you
can't
act like 1p?
understand that a 1
You
degree
sell
bend,
drugs
a
and
1
you
degree bend,
Over the
get a
is
internet.
woman
impossible to
pregnant
detect.
and then you
You are an
don't
utter
pay for the
moron.
child.
You're an utter moron. I can't believe
How
how
many
stupid.
how many children you got that
How
you don't
many
fucking pay
other
child
people?
support on?
Even Chris
And you got a lot of money
understands.
from selling
Even
drugs,
Chris
Rumpus.
understands that this is a
And your
stupid point.
fucking
Rumpus,
your
that
rap
1 degree, that 1
album.
degree would not create that much blockage.
Mind of God, 1 degree for 69 miles. The turbines are about 18 miles out, and then a little bit further for each turbine further away. So you work it out. How much tilt would there be visible?
How much blockage would there be?
Stop shifting.
What are you
How much
talking
tilt?
about?
You raised the issue of tilt. You've just been given the figures to work with. So how
Correlating
much tilt
amount
would there be on the turbines? You're the one that said you should be able to see it tilting. So
How
you
tall-
tell us
What are the
now.
height of those turbines?
What
Come
were
on,
they,
mind of
80
God.
meters or
How
something?
would you go about doing the geometry calculation to work out what the difference to that tilt of 1 degree on those turbines would be in terms of the angular size that you would see, you would perceive?
I'm assuming that math holds that amount of blockage is what you'd expect on the ball.
What are you talking about blockage for? What are you talking about blockage?
You just
What's that
said
got to do with anything?
Rumpus.
Those
Chill,
images,
Rumpus.
you're saying half of the things are being blocked by the water, right?
Yeah, but hold on. You said the thing we're
Some
dealing
of
with at
them
the moment
3/4,
is
some
your
of them
claim.
3/4.
Hold on. We're dealing with your claim, which is you said at that distance we should be seeing tilt that we should be very, very obvious. Now
Right.
we want to need
I-
to
I
prove.
can
We
explain,
want us you to
Rumpus.
do the maths to tell us how much tilt in terms of the number of pixels on that picture of Al's. How many pixels do you think the tops of those wind turbines will be affected by a 1 degree tilt of them backwards away from you? Because they're not side to side; it's backwards.
No,
Please tell us the number of pixels you expect to see different in those images of our case.
I'm comfortable with the 1 degree. I'm saying that if there's that much blockage and you can actually see that much, and that's what you guys claim is the amount that is correct, it would be tilting way more than that. So we know that it's bullocks.
No,
That's
we know
right.
it's 20
That's
miles
right.
away.
Yeah.
Right. Do you not
Well,
understand
listen,
the maths?
Rumpus, let
The
me get a
maths,
word in.
the
Let me
maths
get a
gives
word
us
in,
20
Rumpus.
miles.
Talking.
Rumpus,
The amount that's blocked agrees with the hidden Earth curve calculators. The
Rumpus.
tilt also agrees with the Earth curve calculators.
Rumpus,
So
we're
what's
gonna
your problem?
figure
Hold on,
that
Chris.
out,
Why
Rumpus.
do you keep quiet and then specialize in interrupting people? I'm just dealing with mind of God for a moment.
Because I can't
You
get a
have
word
to
in.
interrupt
Yeah, you can. I'll
Rumpus,
stop for you,
'cause you
Chris.
just
But you seem to specialize in
filibuster
talking when
constantly.
I'm more than happy to give you space. Mind of God, the
Yes.
calculations for the hidden amount for those wind turbines and the tilt perfectly agrees with the Earth curve calculator.
That's the
Chris,
part.
do you want to say something?
That's the part I disagree.
Well, it tells you. What do you mean this is indisputable? We can go and show
Rumpus.
you that the Earth curve calculator will say that there's so much there. Do you want me to do the maths for you?
Let Chris speak, and then we'll come back to this. Sorry, Chris. Go for it.
No, it's the same. It's the same point. But here's what why don't we take a chill pill and why don't we talk about it? I want to know the distance from to the closest and then to the furthest turbines. I want to know the height of the turbines, and I want to know the camera used and the focal length used.
You don't need to know that.
Yes, I need to know that so that I can
No,
get
you
an
don't.
accurate
you
angular
don't.
size of the turbines.
No, you-
Yes, Rumpus.
No, you don't. No,
Chris,
you don't.
look at these people who love technology and precision. No, you don't. You don't need that. Don't need that.
That's because he doesn't understand the geometry. I understand the geometry perfectly. You do not need that information.
Rumpus, we don't know what the geometry is. We don't know if it's curved or flat.
We know the sizes of the wind turbines, and from that you can determine
Chris,
the
check
angular
the chat.
size.
What are
You
the
can
sizes?
determine the angular size in the picture of the wind
No, you
turbines.
can't use the picture, Rumpus. If it's distorted due to refraction, you can't do that.
It's
That's
not
my
well. You can
point.
but it matches. Well, it's not compressed. Those.
I didn't say compression. See,
Okay,
that's
well,
the
whatever
problem. You guys
you
are
want to
using
talk
the
about,
image. No, let me
the
explain.
aspect
I
ratio
figured this
of those
out.
wind turbines
No,
is
Rumpus,
correct.
I busted you. I figured
The
this out. You
aspect
guys
ratio of those wind turbines is
Wrong.
correct.
wrong.
So
It's
therefore,
not. It's not. I figured it out. My last video describes it. Here's what you guys do. You take distorted, refracted 20-mile images. You then use that image to get the angular size, which is from the image that's distorted. You
Correct.
can't do that. You
Correct.
have to use what you would call real-world 2D piece of paper mathematics. You then get the angular size. You then compare it to what's in the image. I'm willing to bet you $100 right now in front of everybody. I swear to God, I'll pay you $100 if I'm wrong. The angular size you calculated is incorrect because those images, if you look at the tops of those wind turbines from the closest one to the farthest one away, which is 3/4 lower, 75% lower, the angular size of the top is almost the exact same. That's impossible.
No, it's not. You didn't look at my pictures.
Yes,
you only
it
looked.
is.
No, if you look at the.
Yes.
Okay, I'll show you. I will show you now. I'll show you where I actually overlaid on top of them.
No, you can't do that, Rumpus.
Hold on.
You're
I will show.
overlaying on top of a distorted image.
It's not distorted. Here we go.
It is. It's got 20 miles of refraction to
This is their
account for.
rigor. They play around in Microsoft Paint to try and prove
Yeah.
it.
No,
But-
listen, mind of God, you're right. All I want is the raw data. I'll do it myself. I'll come up with the angular size of the turbine, and we'll compare.
Okay,
it
well,
to the image.
that's a good thing to do. I'd agree that is a good
Thank
thing
you.
to do.
I just need you to give me those details.
Okay, well, I must admit, I'm in the process of modelling those and determining exactly which turbine is which. I haven't been able to do that yet, and neither has Al K. I will be able. It's about 20 miles, and what I'm going to try and do in that photograph is to identify, actually give you the wind turbine number for each of the wind turbines.
By the way, why don't we see the video of that? Like, how much does that level vary? Is it appreciable, or is that pretty much steady state what we're seeing? The water level, the apparent.
That's utterly irrelevant.
Is it stable, or is that?
Stupid. Yes,
No,
it's
I don't know.
stable.
Okay.
Oh my God.
Well, wouldn't a normal person ask that if they're looking at claiming that that's Earth?
Well, no, because it's not. We're talking about missing 90 meters of things, not the fact there's a tide coming in and out by a few meters.
Rumpus, that's my theory. You're not missing 90 meters. It's magnified due to lens atmospheric cleansing. It's not really that big. And I have other pictures that prove that in my last video. I went to Metabunk. Let me finish. I went to Metabunk website. I found a picture of wind turbines from a guy at the beach who was a baller, by the way. He thought he was showing curve. He took it from the beach, and they were magnified. He went up. Same zoom, same camera, same.
Wasn't the same zoom, Chris.
Listen,
Well, I've looked at the picture. It's not the same zoom, you idiot.
You have to say that, Rumpus.
It's
No,
not.
it's
You
quite
can see
obvious.
it in the photograph.
The
It's not
boy
the
is a
same.
different size as well in the photograph you're referring
Exactly.
to. You're an idiot
because
if you
they're
think the zoom is
because when
different.
you rise above the lower.
So here what? So you're basing your
longer
entire
magnified.
argument. So this is it, Chris. This is what you do. You don't
No, I'm not
realise.
basing it on that.
You say, hold on, Chris. You're basing your entire argument on what some guy said is the same zoom. I wouldn't do that. I would.
No, I'm not, Rumpus.
You
didn't.
are because
I
you're
didn't.
saying the only thing that's
I
your
can
reason
explain
you've got.
it.
Hold on,
You
Chris.
didn't watch
The
my
only
video.
reason, the only evidence you've got for the fact it's the same zoom is the guy said it was. That's
No,
all the
wrong.
evidence you've got.
That's
That is
not.
not reliable
It's not.
evidence.
It's not, Rumpus. I can tell you what happened. I came up with a theory because I was looking at Alke's photos, and the tops of the turbines being almost the exact same from the closest turbine to the farthest didn't make sense because the farthest turbine has to be 3, 4, 5 miles easy furthest from the closest because of how much supposed drop it has, right? That drop, in my opinion, is due to perspective, but it's many miles further away. But the angular size of the tops is almost the same. That is not
Here we
possible.
go. I found the picture. I'm looking forward to show you.
Chris, as I said in the message I left you earlier, you haven't actually done anything to figure out the distance between them, so you're just kind of guessing about that part.
So here we
saying
go.
They must be so many miles away from each other.
Well,
So
of
here you go,
course.
Chris. Here you go.
It would have to be.
Here you go, Chris. The larger wind turbines have less hidden. Sorry, the larger turbines have less hidden, and the smaller turbines. So, for instance, this turbine here, it's down here. Now I'll show you. I'll overlay them. You see this one down here?
Because you're literally drawing lines on this and taking measurements from this picture. Is that what you're doing?
Yes, that's what he did. Yeah, he's an idiot.
Dude, that's pathetic.
I figured that out. My
Rumpus.
God,
That's
I figured that
pathetic.
out before I made
That's
my
pathetic,
video.
Rumpus.
That's why I made my video because I knew they're taking these pictures that have massive refraction, right? 20 miles or more of refraction in some of these turbines.
What does that
Using
mean?
that distorted image
Here
to
we
then
go.
do the measurements.
Here we
It's
go.
hysterical.
Right.
I mean, even like just in general, this is not wise
Right.
to do any kind of.
Here we go, Chris. Here we go. You see
Has
this
anybody
one down
criticising
here?
it been out and done their own
Here we go.
observations?
See this one down here that matches that, and when you move it over to there, oh look, it's a lot smaller, isn't it? And it doesn't look like that because your eyes immediately make the allowance. And there's this one here that's slightly
It's
higher.
not a lot
Oh,
smaller,
look,
Rumpus.
it's bigger, isn't it? And this one over here is also bigger, and it's also higher up. So the point you've just claimed
No,
is that
no.
hold on.
It's not.
Your
It's
claim is that these ones here that are further are missing more are the same size, and I've just shown they're not.
I didn't say they're the same size. I said they're near the same
Well,
size.
they're not. I
The
can
closest
show you,
one
haven't
to
I?
the farthest is about.
Here we go.
Listen,
Look,
Rumpus.
there's the sizing variation there. You see, they're not
Rumpus,
anything
it
like
doesn't-
the same
it's
size,
not
are
accounted
they?
for. I have Rumpus. Listen, it's not accounted for. I have other images of other wind turbines that are a couple miles
So
apart.
not this picture.
They're-
Okay, so
they're
we're talking about
a
another picture
fourth
completely.
of the size.
You made a
They're-
claim for
they're-
this picture, Chris, and I've just shown you're talking bollocks. They're not the same
No, I'm
size.
not.
The ones
I'm not.
further away
the
are
angular
smaller.
size, they shouldn't be that close together. Even the smallest from the biggest is about still 80% of the full size.
Well,
It
well,
shouldn't be
well,
80%.
you need to know the
it should be
distance between.
20%.
Well, don't forget that the amount that's hidden is effectively a squared of the thing, whereas the decrease in size is inversely proportional to the distance. So one is the square.
No, you need to go watch my latest
Oh,
video.
no,
I
you
went-
don't
I
understand.
went and found many
You're
images.
stupid. You're stupid. Listen to what I'm saying. The distance
you're
drop
stupid.
is a function of the square of the distance, whereas the height, the size of it, is a function inversely proportional to the distance. So you're going to drop down more quickly than it's going to go. Then it's going to get smaller. You don't understand that, do you? You're not going to.
No,
take it
I
on
do
board, are
understand.
you?
I do understand it.
You do
I
understand,
found
right?
other
So
images-
I'll repeat that then to make sure you've
Rumpus,
understood
stop
it. I'll try.
interrupting me.
Hold on.
You just
I
talked for
make
2
sure.
minutes.
I want to make sure you've understood that, Chris. So, do you understand the drop that occurs is a function of the square of the distance, but the size reduction is just merely inversely proportional to the distance, which means they'll drop faster than they get smaller. And I know you're not going to take this on board. You're going to get confused, and tomorrow you're going to forget what I've just said.
Rumpus,
That is the reason.
Rumpus, all this talk, I might be right, you might be right. It doesn't
I'm
matter.
right.
At the end of the day, we're going to do the calculations together. We're going to find the actual angular size, not using the image, but using the real world data, the actual height of the target, the actual distance, and the camera used and the focal length used. We can get the actual angular size, and what we're going to do is we're going to find out the number of pixels it should take up. We'll draw that number of pixels, and we'll compare it to what you have.
Okay, well, I will be doing further analysis on this to actually get the full-blown distances to the wind turbines. But if you want to use, if Alk can provide the Zoom thing, you can do. It's an independent way of verifying it, so that's fine. So there's no. Although I said you don't need to do it, and then you can argue it's an extra verification, which I suppose I shouldn't object to. But I will be doing further analysis on this to give you the exact heights that should be missing and comparing it against what we do actually see as missing. And I'll guarantee you that I'll be right. But I don't know whether Alk's actually got the. He did it on a video. I think this
Chris,
clip that
actually,
this shot
yeah,
here is from the video.
I've already put information in the side chat a few minutes ago.
Well, I'm on my phone. Can you go to one of my videos and put it in there or something?
Yeah, will do.
I won't, because when I drop out, I won't be able to get back to it because Jose makes it to where once you drop, you can't come back in or something.
So where did you put that information, Al?
Just took the details off of the photograph that you're using all the time. So it's the
So where have you posted
Zoom
it?
level. It's in the side chat on the hangout.
What side chat? What side chat?
If you hover your mouse over to the left-hand side, a little text box thing appears, and you click on
Yeah,
that. It pops out.
yes, that's right.
Just
And the
scroll up
bottom of
a
that
bit.
is just says Chris. The only comment I've gotten here is Chris. This is a mockery. I haven't seen anything else from you.
Come on, guys. You think the water is bubbling up to that top and then sitting there, and then
Click on
flows?
the-
Yeah, it would be flooding.
The messages are hidden,
flooding.
Rumpus. Click the little up arrow, and it'll expand it.
But now, Al,
Yeah, I've done that. Now,
so
the last message I've gotten here is Chirag Patel. Chris, this is a mockery. That's the
Yeah,
last message in there.
Rumpus is mocking you with this nonsense.
Well, could you put it in the side again, maybe? Because I can't see it either. I just got in though.
Put the details on the side and then.
Oh, there we go. Yes, it's now appeared. It's now appeared. Right. Yes, now it says Nikon
put it in the
P900
side.
f3 to 250 millimeters.
Chris, I'll grab it and email it to you if you.
Okay, yeah, do that. I'm pretty sure I can work this all out. I've got all the online calculators I need. I just need the details. Make sure the actual height of the turbines is in there. Now, it would be. I'll try it on the first turbine. If you're saying it's 18 miles, I would like the distance to the other turbines though. In particular, the very, very last turbine would be good. But
I don't know if you've ever tried this, but it's really difficult to look at a field of wind turbines and identify specific ones.
How is Rumpus doing the calculations if it's that difficult? What do you mean? He's got.
Yeah, how did Rumpus do it then?
I have got hold of the longitude and latitude of all of those wind turbines. I'm then putting it into Google Earth. I'm then also going to make an Autodesk 3ds 3ds Max model of this, and then I'm going to create an image, and then I'm going to be able to compare the image against the model, and then see which turbine is which. It's quite a complicated. It's involved.
Chris, just to confirm, what else do you need? Al K has put the Nikon P900. He's got f6.3, which I think is focal. And then he has 18 miles to the first turbine. Do you need anything else? Observer height?
I need.
You should need observer height. That is a factor, and I think Chris is saying that's at 16 feet, as I remember. You said, Chris. Al, sorry, Chris. Al.
Yeah, I need the focal length in millimeter as far
250 mil.
250.
250
Okay,
millimeters.
Perfect. 250.
And it's 18 miles to the first turbine.
Okay.
Approximately. Al's not sure about that.
Now I'll do it on the first. Like I said, I do need the last because the last is going to have a greater magnification effect because it's going through more atmosphere. So it will be interesting to see.
I will try and provide, as I say, an annotated version of this image, which includes all the turbine numbers. But it's going to take a bit of effort
on all of them or a few of them to ensure that the blockage is consistent on the first one and the ones in the.
When you say blockage, do you mean the hidden value?
No, yeah, the Earth curve. Yes, of course.
The hidden. Where everyone else calls it hidden, and you keep on calling it blockage. Right, you mean the hidden?
Call it nonsense, but sure, I'll call it hidden if that's.
That's what everyone else calls it, right? So the hidden amount. Okay.
I'm also. Yeah, I think from what I remember, because I was working on this last night, I believe that's what I need. I joined up Metabunk, and I'm trying to reach out to the guy who posted those original photos of the wind turbines to confirm if he had the same zoom, the same distance, and all that. Because here's the catch: if I can get a hold of him, or if someone can confirm that that's the case, you guys are in big trouble.
No,
because
he's
you have
made
to say
a mistake.
Listen, no, let me finish.
And if he tells you it's the same zoom, then he's made a mistake again.
No, you have to say that.
No, it's so obvious from the image that it's not the same zoom. It is totally, and he's not lying. People make mistakes like you make all the time.
It's not hard to tell what zoom you're at. You press it all the way.
It's not the same zoom. It's not the same zoom.
He said it was. He thought it showed Earth.
He's made a mistake.
So the answer to this is yes. You can contact Hank001 because that's the name of the guy that you got those two photos from. And what you can do is ask for the unedited raw images, or maybe if they're taken directly from JPEG, maybe he did that too. And what you can do is you can just put that in a metadata program,
sure,
and find out if it was actually a different zoom between those two pictures. But
absolutely,
I think Chris, though, the point's going to be moot because what Hank said was he took one image from the beach and then he trudged up a 24-meter sand dune, and that sand dune could be anywhere behind him, to the right of the original location.
He said it was the same distance.
Then he was mistaken.
Well, maybe the sand dune was right next to it, and there was a hill he went up on, right, like 20 feet away. Like, you don't know. Why would he say that?
It's still 24 meters up. It is still 24 meters up. So it is by definition going to be farther away than the original beach location.
Listen, I can tell you guys are a little bit worried. It's okay. I would be too.
Not worried at all. It's so obvious.
To get the change in size. Listen.
It's totally and utterly obvious.
Yeah.
To get the change in size that drastic, he would have to have gone back like 10 more miles. It's an insane change
it's a
in angular
different
size.
zoom. But a different zoom.
The thing is,
really
you better hope so. You better hope so.
I know so.
No, you don't know so, Rumpus.
I do know so because I've looked at the images, and it's so obvious to me in metal that it's a different zoom.
Rumpus, calm down. Holy shit!
It's the same
all right,
zoom.
so no, okay, so the point is kind of moot because between those two photos, you can't identify the same windmill, anyways. Secondly, he trudged up a 24-meter sand dune. Okay, so 24-meter sand dune,
like 75 feet or something like that. 70
yeah.
feet?
So
it's not that high.
It is, yes. It is necessarily going to be in a different location than the original beach shot because he had to trudge up a sand dune, and both of those pictures show windmills that you cannot compare to. You can't verify one windmill is another windmill from those shots. And he also said that it was something like those windmills vary from something like 34 kilometers away to 46 kilometers away. So you never know if any of those windmills in either of those shots is either going to be 36 kilometers away or 42 kilometers away or 39.
So do you see any windmills in the second shot as big as in the first shot? So you think he just panned around and found some windmills further away when he was trying to compare the size of the windmills over the curvature, supposed curvature of the Earth? Come on, you guys, you're grasping at straws.
He could have chosen. No, you are. No, listen to me.
That I can get a hold of him.
You
listen.
You talked a lot, Chris.
Let's just
you
hope that I can get.
Chris, listen.
You just talked for 2 minutes straight. I talked a lot.
What could have happened there was because he trudged up a 24-meter sand dune, he could have located his camera. Bro. No, listen to me. He could have located.
I get what you're saying. I understand.
Well, how can you hear what he's saying when you keep on interrupting him?
No, we've heard his past presentation. It was
he's trying to say something new here. Let him
finish.
No, he's not. He's saying he's trudging up a hill. I get it.
Yeah, but he was trying.
I was getting to something different. I'm saying, Chris, once he was on top. Listen, once he was on top of that hill, he could have focused the camera on a different set of windmills, because that was a narrow field of view.
No, the point was, listen, this guy was a baller.
I think it is the same. I think
that's not a good point. You're actually
Metal. I think it is the same wind turbine because the boy's there. The boy's in a similar position.
Yes, exactly. Thanks. You guys are grasping.
So I'm not grasping, but he's using a different zoom. It's very simple.
Okay, well, I need to get a hold of him if I can and verify it, or somebody can do it. But
Rumpus, you know that if that buoy was very nearby, let's say it was only 90 feet off of the shore. Well, it wouldn't be that nearby, but you know that if it were somewhat nearby, and it was a
very small buoy that was close, you could get something like. But it looked to me as though it's quite a distance out to sea. So I think what you're about to claim, I wouldn't really agree with what you're about to claim.
The buoy looks considerably smaller in one shot, which is the one once he was on top of the sand dunes. So that sand dune could have been, who knows, 300 feet away, 200 feet away, and he could be looking at a completely different set of windmills. So there's not enough.
The buoy is in the middle of the frame.
Actually, no,
it's metal.
It's in different places on this.
Metal. What you say is just about possible, but unlikely. I think it's just much simpler. I think it's much simpler argument simply to say he didn't use the same zoom, because what you tend to do, of course, is if you're going to club a sand dune to protect your camera from sand, you pack, you put the zoom down, you get the camera back into its case or whatever, and you retract the lens, and then you go up and take another picture. So you're not going to maintain. I suspect you wouldn't move around with the thing in the same zoom position.
If he moved, if he moved laterally up a 24-meter sand dune, okay, if he moved lateral to the point on the beach that he shot the first one, that buoy could very well be in a different place, or it will appear to be in a different place, and it could be a different set of windmills.
Okay, good, great. So,
but the thing also, the buoy and the windmill seem to reduce by about a similar amount. So that's again why I think it's the same thing.
Chris, do you mind, just for the sake of the rest of us, kind of take a step back what you're referring to, just to help us understand this dialogue?
There are two pictures. If you go to the Metabunk thing, there's a two-picture thing showing a picture of some wind turbines.
Can somebody pull up the link?
I can't remember where it is off the top of my head. You're the one.
Go to my Mind of God. Go to my YouTube. In my last video, there's a link or somebody.
I'll do it. Yep. I can share my screen.
There's a link in my YouTube description. You don't have to watch the video. It's the last link to the Metabunk. About three quarters of the way down, there's two images from a guy called Hank 001.
I'm on it.
So that guy, I'm just going to tell the story. Rumpus, don't interrupt me. That guy says he took from the same distance to the turbines, the same zoom, but different heights. And you get a drastically different effect from the first to the second shot in terms of the angular size of the windmills.
No one's disputing that.
My theory is
you haven't considered he could be wrong?
Oh, God. Just interrupt. Just fucking Rumpus the shit out of me.
Yeah, but no one's disputing what you're saying, Chris. Yes, we know that the things are two different sizes. That's not in dispute. The cause of it is.
What's the cause then, Rumpus?
The cause is the fact that he took them with two different zoom settings. Oh my
that's
God!
Your theory. That's your theory. If we can,
It's so obvious from the picture.
Rumpus, if we can get a hold of him, we'll have to confirm that.
Yeah, no, he's made a mistake, and he may make the same mistake again. He may misremember.
It's really
Well,
simple.
we'll
You just get the original files. You get the metadata for the field of view. You can go to EXIF tool and drag and drop it into it. I mean,
assuming it's not part of a video.
Yeah, assuming that it's not part of a video.
I gotta go, guys. I'll see y'all later.
So, no, but yeah, what I'm saying, Rumpus, is it's actually very, very possible if he moved from his original beach location, went 24 meters up a sand dune, because sand dunes can be they can have very broad bases. So
yeah, I agree.
Yeah. So he could be as far as 300 or 400 feet laterally from his original location, and in that case, if you move from side to side like that, the buoy's position is definitely going to change if it's very nearby. So I'm saying there's no identifiable things in those photographs where you can without a doubt compare one windmill.
I can share my screen. It actually says on the let me show you.
Yeah.
Share screen. Just confirm to me that we're talking about these images, because I just went according to what Chris told me to do. Let me know if you guys can see my screen.
I can't see it yet.
I've found them.
Can you see it?
Oh, actually, he has moved a bit to the side. Let me show you.
But he says same distance, same zoom. If we're talking about these turbines, he says it right at the bottom of his images.
And look,
he has moved a bit to the right. I must admit, yeah.
Yeah, there's nothing in those two photographs where you can confidently compare which windmill is to which windmill. So even if you get the metadata on this and it says it's the same field of view used, it's kind of a moot point. There's no frame of reference here, because, and also it said on the very top of that post, these windmills are from, I believe, 36 to 45 kilometers away. So,
but he does say that he's staring at the same thing, because he says also notice the buoy that shows that you can see further away from when the standpoint is higher. So he's comparing the two images and using that as the anchor point of commonality.
he's simply demonstrating that when you go to a higher height that you can view things from, then your horizon broadens. That's
fair enough. I don't know the full argument, but I'm sure these two images are the same thing, because he's stating that.
Yeah, and
they are quite different actually. The buoy and that isn't. You can't relate any of the wind turbines in the top picture. You can't find in the bottom one. I must admit.
Yeah, exactly. That's the whole point of this. It is kind of moot to really harp on these two images because there's not enough in there.
But I suspect
a
one is
very
in the
definite
I suspect
conclusion.
I suspect that one in the center is the same one, though. I suspect that one because can you imagine if you were to the left of that buoy, then the turbine. If you look at the second picture, there's one in the middle of the picture, and that's to the. And if you can imagine, if you were to the left of the buoy, as you are in the first picture, you could imagine that that particular wind turbine is the same one. Although you can't verify, it's very difficult to do this sort of 3D. Yeah, it's very tricky. Actually,
this whole environment is a dumb way to test for anything. Agreed. It's retarded.
I mean, you're having to rely on what he's saying here, and I think he's just made a mistake. It's quite simple.
You guys think that water is swallowing these windmills, and that's the Earth curve?
Yes. So you idiot! You think they're 90-meter waves, do you? Because those things are 90 meters tall.
No credit. I mean, if you want to believe that.
So if you want to believe in 90-meter waves, you can. If you do, you're an idiot. We've never had such things around this country. You idiot.
Let me just jump in and confirm.
It would be every other variable that could be out there potentially, except Earth curve. So correct, yes.
Let me jump in and confirm.
You think there's a possibility of 90-meter waves? Do you idiot? Jesus.
He's making an argument from incredibly.
That's more sane than believing that that's Earth curve.
No,
you think a 90-meter wave is more sane? That's a monsoon, bro.
That's more than a tsunami. You don't get tsunamis with 90 meters.
That's a tsunami, not a monsoon.
Are you kidding me? Oh my gosh, dude.
tsunamis only tend to have about 20 meters.
Earth
You're an
curve
idiot. The
tsunami.
90-meter wave is completely unknown.
It's a tsunami with the way that looks.
No, it's Earth curve. You're looking around a ball, you idiot. I mean, you don't seem to have any basic understanding of geometry.
No, I mean, if you want it to be a ball, go for it.
Well, it is. That's what the facts say.
Yeah.
We want to, yeah.
Oh my god, you're just a troll.
I mean, to make up 90-meter waves, I mean, you're just a moron if you think that. Is even a possibility?
I'd rather take that stance, even though
because you're a moron and you're just obsessed.
If you believe
You're
the water is ramping up that high and then forming like a waterfall,
it's not up that high because everything on the curve is the same height. Of the water's all the same level.
No, I mean credit to you if you believe that. That's
Mind God, you're saying that because that's called cognitive dissonance right there.
Jeez, no, he doesn't understand geometry. It's just amazing. This guy claims to be intelligent and he doesn't understand the basics of geometry.
He made the statement. What is cognitive dissonance, Fletcher?
God, I mean, how stupid can you be?
I personally think Mind of God is just playing a game.
Yeah, I mean, he can't be. Can he be this stupid?
He wants to rally you up, Rumpus.
Yeah, I mean,
Earth is flat, so that's why.
I mean, can he be this stupid? I mean, what's the consensus here? Is he really this stupid where he thinks there's a 90-meter wave here?
Slightly absurd that the water is climbing up that high and blocking those. You don't think that's a little bit?
Water doesn't climb. It's on the same level. You're on a curve. You don't understand what a curve involves, do you? I
don't. Agreed.
I mean, you're a moron.
Correct.
Let me just show you what. Let me just show you what's happening. I mean, you don't seem to understand. Let me go share my screen here.
He's gonna be more compelling and absurd than what I just saw.
Rumpus, can you place a Rubik's Cube beside the wind turbines so we can extrapolate?
No, Carlos, what was that word you just said? Encapsulate? Encapsulate?
Yes, extrapolate.
What does extrapolate mean?
Extrapolate.
You know better than me. Please.
Yeah, no. So don't use words you don't understand.
No one knows what you meant.
Mind of God, you asked. Mind of God, you asked me what cognitive dissonance is.
You just said
you asked me what. Mind of God, you asked me what cognitive dissonance is.
Yes,
correct?
Yes, correct.
So it's when you have a belief and then you're presented with facts that contradict that belief, but instead of saying okay those facts are valid, you stick to your own belief despite the facts that you're given. That's cognitive dissonance.
I'm not given a fact yet, sir. Sorry. I have Rumpus taking his crayons on an image and trying to get.
So here we go. So this is where this is an image. This demonstrates to you how what you don't seem to understand is all the points on this curve are at the same height. So there's nothing going uphill or downhill. That's where it represents the water level. All the points on this curve of this surface of the sphere are all the same height. They're all the same distance.
Rumpus, you walk me through this. I think what Chris was suggesting and what we do, whether it's on a private thing or whatever, let's go through that stuff you just presented right there, that math, and do it on the image. And again, he's obviously more into this than me, but I would like to be on if you guys will have me. I want to walk through those numbers.
Okay, well, I'll try and identify the locations of each one of those wind turbines. I'm in the process of doing it now. I've got hold of the latitude and longitude coordinates of all the wind turbines, and then I'll try and identify them. But I've tried to do this for several hours previously, and
how did you do the analysis beforehand if you didn't have this? Like, I thought you were using that as an earth curve proof.
Right, because I didn't use this. Well, I'm using it as a proof of the fact that you can clearly see that the wind turbines are hidden. So that is proof. So that's proof in itself. But what I didn't do is I didn't go and do the maths on how much it's hidden, because I did that in my other part of my presentation. Hold on. In other parts of my presentations, I go through the maths and I work on something on the Isle of Man observations. And where I go into very great detail with the maths, and I show, for instance, where the exact position of something called the Morgold Lighthouse, and I go through all the maths intricately, showing exactly how much should be hidden. You can see down here, and I even then use the ray tracer that we've generated to create. Here we are. Here's the Morgan, and I go through the exact numbers of how much should be hidden by the Earth curve.
Who wrote the code on that? You or Philip? Who's the author of the code for the tracer?
That's Philip.
I'm just asking. Thank you.
And he and we sort of guided one another. He actually wrote the low-level code, but I sort of got him to do lots of bits of the actual refraction.
I only asked that because I've looked at the ray tracing code when I told you I was shooting seismic rays, and it's extremely dense. Like, I just looked at it out of curiosity, and I'm like, I would have no hope of writing something like that. But keep going.
Rumpus, can you debunk climate change?
I'll do what?
Can you debunk man-made or anthropomorphic global warming?
Well, why would I want to do
Climate change
that?
is real. We live under a dome, so it is changing. It's heating up.
Because there's a conspiracy that the climate change science is not real science. Have you ever looked?
Well, this is rather off topic, P Mars, and I'm not really inclined to
Do you have
talk to
any
you
pictures
anyway.
of the dome, man of God?
Could you just answer the question? Have you ever looked into it? You haven't looked into it?
It's quite obvious that we pump lots and lots of heat into the atmosphere, and obviously that's going to cause temperature changes.
Yeah, exactly. Of course.
So it's quite obvious.
So you don't know. You don't know then.
Well, I do know the climate change is definitely partly the result of human activity.
Exactly. I don't know how.
And what's more, the temperature changes in the atmosphere are changing at a greater speed than they've ever done in geological history, and we can show that from our knowledge of the geology.
How can you prove that it's humans are the cause?
Because, well, it's happened in only the last 100 years, these dramatic changes. And for instance, we've seen the change in size of the Arctic shelf. We've got much more quickly than we've ever had it before. And we can also show the amount of carbon dioxide we've introduced is increased by boring into ice samples in the Arctic, in Greenland. You can see the amount of carbon dioxide that we've increased it by, and we can show that over the last 100 years it's increased more than ever in any recorded history in the previous ice cores prior to that point. So this is definitely unusual times, and what's more, and then we're getting all this melting of the ice caps and the temperatures increasing at a greater rate than has ever happened before. Those two things, I mean, you can't prove it. This is by induction, by saying, we've got these two events, one which we know will cause an increase in temperature, and then we can see the increase in temperature. Now, it's like saying, if I poke you in the eye and you scream, well, you can't prove it's my poke in the eye caused it. Could be, it could be an invisible green pixie making you scream. But the two events are so circumstantial. The circumstantial evidence is so great that we're going to say, yes, it is the cause.
Carlos, what's proof by mathematical induction?
He's too busy doing something useful.
Okay. There's really no such thing as proof by induction.
There is.
I mean, it's generally deduction.
No, induction. You solve for n equals k. You solve for n equals k plus 1, and you can apply it recursively.
There's a difference between mathematical induction and induction in science, Metal.
Yeah. Okay.
It's a real thing.
Well,
yes, you can do mathematical induction that are in fact proofs. If you prove it for n is equal to n is equal to 1, you prove it's n is equal to n plus 1, n plus 1, then you can show that it will carry on. Yeah. So there are proofs in maths. You can prove things, and so induction in general you can't prove. That's because science is based on, for instance, induction is such that I see the sun go over us every day, rises every day. So by induction, I'm then going to say, well, it's going to happen tomorrow, and so that's physical. But it may not. So you might be wrong. And similarly, all these effects we see when we do experiments. If we drop something 1,000 times and it falls to the floor 1,000 times, so by induction we then say it's going to happen on the 1,001st time. But you can't prove that. It could be that it doesn't do it the next time. But we rely on all our physics and things and say it does. It could be there's some other effect that would cause it not to do that. But so science is basically around measuring things repeatedly, seeing if you can draw some sort of pattern from it, and from that you induce by induction to say, well, the general case, and saying, well, that's what the general case is, and then you use deduction, obviously, to then make further predictions. But science is fundamentally based on induction, and basically seeing if you repeat something and it keeps on happening, then you end up with a general rule and becomes a theory after you've proved it.
The induction variable in science would be a lot of times time, because you might do it again at a different time, do it many times. It's the same concept.
With different environmental variables, you isolate your variables, of course. And of course, you see, it could all be that the dropping of my pencil when I'm dropping on the floor, it could be that it's not down to gravity. It could be it's due to invisible green pixies doing it, who just like to go around running around emulating gravity. And then it's on their day off in year 2052, on April the 25th, they decide not to do it anymore, and it doesn't happen. We can't prove that. It's very unlikely, but you can't prove it.
Viable case.
Or if the Earth stops spinning.
But you can't prove that, you see, whereas with mathematically you can. Well, that's the difference.
I derailed the convo, sorry, but you were talking about these images.
Yes. That's right.
So you're going to go through this?
Yes. So, right. So your argument was, why haven't I done it for these images?
I thought you did. I thought that's why you keep.
No, I haven't. No, I haven't been through the maths on the windmill turbines. I'm just showing them as an example that they were being hidden, and therefore as a general principle. And then I go into the specific numbers.
Now you're turning into a magician, dude. I thought you actually walked through it and had some comfort that is truly.
I have other examples. I have a whole wad of examples on the Isle of Man features, including the lighthouse, where I go through exactly the maths and the distances. But because I couldn't identify the exact distances to those wind turbines, I haven't done the maths on the wind turbines. I will be doing over that the next few days, and I will be incorporating that into my presentation.
I think Larry should only really talk to you, because him talking to like Fight the Flat Earth and others, to me, is a waste of his time. Like, if you guys set up with Jose a session and just, go through that would be, people can take whatever side they want, but that would be very educational.
Yes, well, I'm intending to give a something like a 6 or 7 part walkthrough of my website on this, and which goes through all of refraction, the theory, the geometry, how Snell's law, refraction, the Fermat's principle, the ray tracer. As a whole, it's so long. It's a 170-page web page.
But Rumpus, your position is, even not knowing the atmospheric specifically, some information can be extracted from this, or how much do you need to know about what was happening in the air when this?
And the examples that I take on specifically, Philip and I got the meteorological temperature conditions for that day, and then that's what the examples we considered, which are 2 videos done by Anthony Riley. We got the meteorological conditions for that day, so we were able to emulate the exact refractive conditions, and then we were able to model that in the ray tracer and then match that against what he saw. I haven't done that with the LK thing because that came along later.
Is all your modeling based on far distances, or does it collapse locally and work just as well, or does it?
It works at any distance.
Okay.
What it can't cope with is variations along the line of sight. So, for instance, if you have a lump of warm air between you and the object.
No, I understand why that. Yeah, I agree. You're assuming that the medium is homogeneous from target to observer.
Correct. Not vertically, but horizontally it is.
Understood. No, I know that I definitely agree you would need that. Fair enough. Or else the image would be distorted. You wouldn't be able, you'd be missing chunks of the image if it was luminous.
Yeah, well, what we did think, that if we had something like a ripple. So, for instance, if you're looking at one of my images of a rippling road and you get inferior mirages, we actually thought we could actually include in it sort of ripples if you wanted to include something in terms of the change of the height of the thing in a direction along. So there's some things we could do, but the actual gradient of what goes on in the air we wouldn't be able to change, at least not easily, without making it very, very much slower. So we assume in other words, the temperature next to the observer, say at 10 meters, it's 20 degrees C, and at the ground level it's 10 degrees C. We assume that temperature gradient exists all the way from us to the thing we're looking at. Otherwise,
ground up and left to right, assuming there's a smooth profile, right?
That's right. Left to right and away from you in the Z coordinate, we assume that there's no change.
Understood.
But up and down, we do allow for any arbitrary. In fact, we can emulate superior mirages, inferior mirages, any sort of miraging that you can see, which always tends to be, if you look at them, they all tend to be vertically different. They don't tend to change horizontally. So we can model all of that potentially.
Is there a distance that you would acknowledge the ray tracer would not be able to honor with the or you could always just loom it a bit more or something like
the ray tracer can deal with any distance.
No, I understand that, but let's say as of now, your current understanding, do you have boundaries set where you could even say on the modeling, as of the current understanding now, we literally under no atmospheric conditions could see the base of something this distance away, whatever that number is, this distance.
The limit would be a great circle route, correct?
Exactly, and in fact, there are curvatures that indeed effectively go around the Earth, so you can see if you had a sufficiently powerful telescope and you didn't have attenuation, which obviously you tend to do, you would in fact see your own bottom.
Oh my God! So we'll never be able. Okay, fair enough. So at least you're honest. We'll never be able to. That will never be compelling for you to see something far away. Ultimately, it's just
because I can demonstrate to you.
Sure. Fair enough.
In fact, in the observations that Anthony Riley did, he's got exactly those conditions. And what's more, I can quote several scientific papers in which this exact same thing happens as well. This is documented, validated, verified, and part of the body of science.
So why aren't things loomed up then when there's obstruction bottom up? You're just saying it's the atmosphere that's not allowing the.
Well, it depends on the conditions. There's a
Fair enough.
standard looming,
Sure.
and then depending on the conditions, when you get extraordinary conditions, then you get super looming. But
Understood.
most of the time, you just have standard looming, which
Got it.
will only go so far.
Fair enough.
Isn't Rumpus isn't what you call super looming? They're referred to as circular rays sometimes.
Yes, correct.
Yes.
It's actually more than that. That's just a special, one particular super looming. But yes, you're on the right track there. Yes.
Yeah.
But you can but some of the rays are actually more curved than that.
But point is, mind of God, any kind you have super looming anytime you have super looming or circular rays, that's a very rare case. I mean, it's not like you can stamp that to the atmosphere at any time.
Fair enough.
It's very, very rare instances of that actually happens.
The only reason I know you guys will beat us, unless some major change happens in the world, is there will be no reason for anybody to fund these things over a large flat plane. It'll just never happen financially because no one would do it. So
the thing is, you can identify when these happens, because when you get these circular rays, as Metal correctly called them, or I'm calling super looming, which is, in other words, anything that's approaching a circular ray or more, you get very considerable compression in the image. So in fact, you know what's going on. And so when Ranty comes along and says, I've got this highly compressed thing, you know that you're getting something similar to circular rays or superlumin, as I call it. So they're very distinctive. So what you won't get is being able to see having all the way around the Earth and it looking like a uniform, normal aspect ratio object. It won't. It'll be heavily compressed. And something like the circular rays, it's super compressed. So it's not as though you see normally and you can see around the whole world, not due to attenuation, you can't obviously anyway, but there are giveaways as to when this is happening. And one of those giveaways is the fact that it's heavily compressed.
But so those bottom rays are essentially being angled up and going, quote, further, right? In those looming scenarios, it's going over the curve and then being able to be
and it's following the curve. Exactly. That's what circular rays are. They actually follow the curve of the Earth. So you can in fact see all the way around, as I say, in theory, all the way around to your bottom. Obviously, it'll hit the mountains and God knows what, and be attenuated. And you obviously need a huge magnifying glass. So
I mean, if you didn't have occlusion from the atmosphere, you could possibly do that. It would be super distorted, but
yes.
So the atmosphere eventually occludes things. So
attenuates it, so there's particles and things, and eventually it'll disperse, and just due to atmospheric attenuation, you will not obviously see that far. But in theory, if the atmosphere was perfectly clean, didn't have any dust and stuff in it, and there weren't any mountains in the way, you could, in theory, under these conditions, see all the way around to your bottom. But obviously, that's the amount.
In my test, Rumpus, if I would have gone back and I could do it, it's just like literally tie a piece of string to my sock and then it's really, really long yarn and walk away. And then I can show that there is literally a physical line from my foot to the height of the camera where it's, registering that video that I did. That would be enough, at least, again.
That actually is an interesting idea, yes.
Right. Because, and I think I appreciate yours and Dean's and everybody's point now. You guys believe, and makes sense, that a light ray physically will not be registered unless it's obstructed.
Correct. It follows a straight line. Yes.
You're not even necessarily concerned too much about level. Obviously, that's why we're here talking about the shape. But you need a unobstructed path from, for example, coming off my socks to the camera.
Correct.
Okay, got
exactly.
it.
And when you're standing on a flat surface and the camera's above the flat surface, there's nothing to get in the way.
Okay, and in a controlled environment like that, there'd be very few things that one could explain that away, except for the fact that the camera is indeed registering the light from my socks. However, it's being I call it voted out, but it's being replaced with the ground.
Right, but the one thing you need to do better, if you were to stick a little red dot on your sock and also put a red dot on your head to make sure that it's nothing to do with the fact that you're getting so far away you can't see the red dot. So you should put something clearly identifying in the sock and also put it on your head so that we can then see if the red dot on your head has also disappeared as well.
Correct. That's why I wore a white hat and white socks, but I know what you're getting at. Yes, I tried.
Right,
I have dark skin, so it's like easy to tell that my hat.
A little red dot. Put a piece of paper, something sticky on it. Put some felt tip pen on it in red and on your head, and then if
put a clown nose, Rumpus. How about that? I'll put a red dot on my nose. Well, when I
Okay, and a red nose on your feet. Yes.
Don't you have one on your forehead?
I could do that as well. Yeah, my mom would be happy if I did that. So I can do all that.
Hey fellas, I gotta roll. I just want to say have a good day.
Yeah, all right.
I'm going to go as well, actually. So
Take care, gentlemen. Thank you.
I'm on stick around.
See ya.
Bye.